All right, we're going to look at max height now. So for a max height problem, you know you're dealing with a max height problem because you are at that maximum height location. That's one of your start or your end points. If that is true, the velocity at the maximum height is 0. Now, the example we're going to do here is a person throws a ball up, leaves their hand at a height of 1.2 meters with a velocity of 12 meters per second and flies up to a maximum height. And I want to know, what is that maximum height? So it is a max height problem, so it ends at a maximum height. So that tells me that this velocity right here is 0 meters per second. Now, I do kind of draw it like it's a parabola because it does form a parabola with time, but really this is a one-dimensional motion problem. So I do list my variables for that one-dimensional motion problem. As soon as it leaves the person's hand, gravity is the only thing acting on it, meaning we have a free fall problem, meaning the acceleration, assuming we're on Earth, of course, is negative 9.8 meters per second squared. Again, that negative is just telling me that gravity is pointing down. It's trying to accelerate that object back toward Earth. The ball leaves from a height of 1.2 meters initially. I'm trying to figure out how high it gets, and the initial velocity was 12 meters per second. Now, I don't know the time it takes to get there. So what I'm going to do is I'm going to go ahead and I'm going to pick an equation that has no time in it. So the equation without time is going to be number 3, which says v squared is equal to v naught squared plus 2a y minus y naught. And what we're going to do now is we're going to cross out anything that's 0. So the final velocity, the velocity up at that maximum height, is 0. Okay, and we need to go ahead and solve for y final. So I'll subtract this v naught squared over. So I have negative v naught squared. Now I'm going to put those parentheses on there just to make sure you know that that negative sign is outside the square. Equals 2a times y minus y naught. I'm trying to solve for y, so I'm going to have to move that 2a over as well. So now I have negative v naught squared divided by 2a equals y minus y naught. And the last thing I need to do is take that negative y naught and add it to the other side. So now I have y naught plus v naught squared divided by, minus there, minus 2a equals y. Go ahead, plug in your numbers now. So it starts at a height of 1.2 meters. Okay, minus, now it's not going to end up a minus because we do have that negative sign down in that acceleration. So we will be adding to the height of 12 squared divided by 2 times negative 9.8. So those negatives do cancel out. And I end at a higher height. So I plug that into my calculator and I get a maximum height for this throw of 8.85 meters. And there we have a maximum height problem.